Welcome to the 1971 Nobel Prize in Physics, which went to Dennis Gabor for his invention and development of the holographic method. Now, he did this work for photographs in 1951, but he actually originally did some of the work in the 1940s trying to help electron microscopy with some resolution images they were having. So really, it was first done with electrons, but then later done with photographs. I remember 51, not that terribly long ago in the large history of man. Now, the 1800s were actually where we started seeing photographs develop, but this sort of happened in the 40s or 50s. So, and it didn't take long for this stuff to really catch hold and see commercial application because, like the 1970s, even I as a kid remember getting some holographic baseball cards that had these little three-dimensional images of your favorite player. The 80s, you could see, in malls, we had stores that had photographs nicely framed of famous people that were holographic images. We still see these things in museum, and you probably have some of them in your own home, and you may not even realize what I'm talking about just yet, but you will. Now, meet Dennis Gabor, a guy who changed a whole bunch of stuff in medical imaging, and even in trying to protect us from counterfeit currency. Interesting guy. Let's dive in. Now, in the very sort of mid to late 1800s, we started seeing photographs kind of becoming more commonplace. You get them around. You probably had them in the early 1800s, but realistically, for most widespread use, you saw it in sort of the mid to late 1800s. But they've been greatly improved since then, obviously. But those were just two-dimensional, right? Flat images. You had to hold really still while somebody took a picture, they've gotten much better. But that was sort of all you really had. And then in the 1900s, it got better. We added color, we did other things. But then in 1951, along comes Dennis, and he took this thing he did for electron microscopes, and he said, "Hey, I think with a camera, you could actually add the illusion of depth." So what he did was he used a method based on interference, which is, sort of how certain light rays interact with each other. And he also used a coherence, which is when light is aligned in phase with one another. Light waves are aligned in phase with one another. And what he did was, light that hits me or you or my coffee cup then reflects into a camera and is captured on film along with a reference beam that did not fall on the object. Now, when that reference beam falls on the developed film, the light is then bent so that a reproduction with depth is produced. So, what you get is this sort of use of a reference ray or reference beam along with the actual object to give you this sort of illusion of three dimensions on a two-dimensional surface, and it works pretty darn well. Today they are used in all sorts of ways. So they are used to eliminate counterfeits in credit cards. Probably seen a credit or debit card with a little holograph on it, and that helps eliminate counterfeit versions of those. You've seen it on uh, paper currency has some little holographic strips in it to help eliminate counterfeiting. Uh, Data storage with incredibly high capacity is used uses holographic methods. Medical imaging, engineering analysis, artwork in museums. And even at still used in scientific labs. In fact, the lab LIGO that was partially responsible was well just responsible for the discovery of gravity waves uses holographic techniques in its data analysis and capture. So this stuff is used all over the place every day. I've got, a couple of debit cards and credit cards in my wallet that have holographs on them. You've probably got them in yours. And it was all thanks to this guy who was trying to help improve the resolution of electron microscopes. He succeeded in doing that, but he also succeeded in making the world a lot harder place for counterfeiters in the process. But what else did he do? So he was kind of an interesting guy outside of that. But let's dig in a little bit more into his career outside of that. So outside of his work in holographs, he was a European physicist who was born in the early 1900s. He was of Jewish heritage, and as a result, he was one of the people who fled Nazi Germany in around 1933. And he left and he became a British citizen where he spent most of the rest of his life. He never renounced his British. He stayed a British citizen. He was in and out of different parts of the world, but he moved to Great Britain in the early 1930s and never looked back. His original work on holography, like I said, was based on the electron microscope, and therefore used, electrons instead of visible light. But then he saw the potential in it, and he kind of went another way. with it, which was thankful that he did that. In 1958, he actually patented a flat screen television concept. So he was kind of the first person to get on this. Hey, let's get away from cathode ray tubes and these really heavy things into something more flat screen because then it doesn't take up your entire room, which is a good thing. But at the time it was just too expensive and difficult to manufacture. And it's not the same technique that's used today. Now today is a much different way of doing them. But he was thinking ahead, right? So he was thinking that way in the 1950s. In 1963, he published a book that I've actually read called Inventing the Future, which had a lot of interesting points in it. In fact, he coined a phrase that it gets used off and on. So the future cannot be predicted, but futures can be invented. So, the interesting philosophical statement from our scientists there. And I think he's right. You can't necessarily predict the future, but you can sort of work to change your own future if you think of it that way. And in that book, he discussed what he saw as the three major threats to modern society. One of those was war, but if you think about where he fled from, that at the right at the end of World War II, that sort of makes sense. But he wrote this in 63, so he'd lived through World War II, Korea, he saw Vietnam ramping up. But war is something we do need to worry about, and more importantly, the destructive capability we have now is much different than it was in 1942 or 1941 or even 1944 when they were 45 when the Manhattan Project was in the mid 1940s when we developed the atomic bomb and dropped them in Japan. The destructive capability we have today far exceeds what was around then. One of the other concerns he had was overpopulation, because there was and still is concern of can we produce enough basic food and necessities, and can everybody afford to have what they need in life to survive? That does become a big question. And he lived through the sort of the Weimar Republic massive inflationary period that impacted Germany in between the two world wars. So too much population, not enough to go around, shortages of things, that sort of does stick into his writing. And he was also concerned about what he called the age of leisure, which is an interesting thing to be concerned about because he said, if we do get to a point where we can produce enough so we don't have these sort of shortages where we don't really have anything that's scarce. So the age of scarcity is gone, and there's really enough to go around for everybody. It's inexpensive and it's whatever, and we have this age of leisure. What happens? Do people just become completely narcissistic weirdos, or do we actually kind of become more of an intellectual society? So he said one of the big threats was what happens when you reach a point where not everybody has to go out and work like crazy to survive. You reach a point where you don't have to work as hard to survive. And then we have this sort of age of leisure, which could lead to its own set of difficulties. And having seen the movie Idiocracy, maybe maybe it's true. Um, but he was an interesting guy. His writing was good. It wasn't great. It wasn't just sort of scientific in nature. It was as much philosophical as it was science. And sometimes that's an important thing for scientists to consider is what happens later on as a result of all my work. And you can't necessarily stop the work because if I don't do what I do, maybe somebody else is probably going to do that same stuff. But if I do it, can I guide it in the right direction and launch it in the right space? So, there's sort of that philosophical discussion you need to have with yourself as you do this stuff. Interesting guy. I highly recommend his book if you get the opportunity. It's not hard to find. But if I hope you enjoyed the video, please don't forget to click like and subscribe, and we'll see you on the next one.